Hi friends, welcome to follow up. In this video, we are going to look at another problem related to palindrome. That is problem 234, Palindrome Linked List. This video can be regarded as a continuation of the videos for problem 125 and problem 2108. So in this video, we are going to practice some linked list operations. So here in this problem, we are given the head of a singly linked list. We want to return true if it's a palindrome or false otherwise. So here are two examples. In the first example, the corresponding list is 1221, which is a palindrome list. While in the second one, it's corresponding to 12, which is not a palindrome list. So here the constraints are the following. First, the number of nodes in the list is given by the closed interval, say 1 and 10 to the power 5. So in other words, the number of nodes can be as many as 10 to the power 5. So this basically determines the problem size. And the node values are digits, starting from 0 and ending at 9, both inclusive. So actually for this problem, so if we want to check if the corresponding list is a palindrome list, is actually very straightforward, right? So here the main point is the follow-up. So could we do it in O(n) time but in O1 space? So here the O1 space is the key point, right? So we are going to make an effort towards this. So with that said, let's look at the code. First, I'm going to write a traditional solution. So here, so we can see, let's use an array, right? And then what we are going to do is we are going to do a linear scan of the linked list, and then we get the corresponding number list or Python list, and then we check if the list corresponds to a palindrome. So this is the basic while loop, while head. So we are going to append the head value, and also we want to set head to be the next, right? So here we also interested in know the length or the number of nodes. Let's use an n. N is a counting variable. Each time we do a append operation, we are going to increment this n by 1. So this way, after we exit this while loop, we have a corresponding number list. So we can print out this just to have some intuition. So for example, this example, we get this 1, 2, right? And then what we want to do is to check if this is a palindrome list. So this is very simple. We just need to check n/2 pairs, right? So basically for I in range n/2, right? And then we check this beginning one and also the one in the other end. If these two are not equal, right? Ox n minus say n minus 1 minus I, right? Then we directly return false because we know it cannot be a palindrome. If after we check this n/2 pairs and all of them are equal, then we are sure it's a palindrome. We just return true. So this is the one format of solution, which is very straightforward. But due to the use of this auxiliary list, the space-time complexity will be O of n, where n is the number of nodes. So let's do a quick test. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. So this is the one solution, right? However, this solution, as we mentioned, is n in space. So we can do better. Actually, we want to achieve O1 space. So this will require us to do some linked list operations. So this actually can be very straightforward if you can decompose the problem or the task into small tasks or problems. So let me copy this function signature and put it here. So I'm going to call this one version v1. Next, we are going to, our goal is this. We are going to break the linked list into two parts, right? and in the middle. And then we reverse the second part. And for example, in example 1, so the first half corresponding to 1 to 2, right? And then the second part, if we reverse that, then 1 will point to 2. We have another 1 point to 2, right? So you compare this head currently at 1, 1. So these two heads has value coincide. And then you continue. If you met values that are not the same, so it's not a palindrome. Otherwise, after you finish the check, it will correspond to a palindrome list. So that's our idea. So here there are two things we want to do. First is find the middle, right? And the other is reverse a linked list. So these are actually very standard operations in linked list. So if you are interested, you can actually check out some of the videos in my linked list playlist in the channel. So for now, what we are going to do, I'm going to first write two hyperfunctions. So let's see, write two hyperfunctions to achieve our needs. So it's specified here, right? Find the middle and reverse the linked list. So here I can do first find, let's see, find mid and its father, right? Because we need to, for example, here we want to find this one. Also, we need to find the previous one so that we can break the link. Then we can reverse the second half. So here the what passed to us is a head, right? So then what we are going to do is let's see, we can set a previous to be null, and then we are going to use fast slow pointers, right? Slow equals the height, and fast also equals height. And then later, each time if fast and slow can move forwards, so we move slow 1 step ahead, and while we move fast 2 steps ahead. Then when the fast arrives at the tail, the slow will pointing to the middle. Of course, in between you need to think of if the number of nodes in the linked list is even or odd, but we will absorb all the two cases into one case. So with that done, let's do this. Well, fast and fast next. The reason we check fast next is due to the fact that we are going to do this. Slow, we move 1 step, right? And then fast, we are going to move fast, next, and next. So because this next is not null, so we can call this next attribute, right? So then also because we want to keep track of previous, so we can see previous equals slow. So with that treatment, then we can return previous and slow. The slow will correspond to the middle node, and the previous will correspond to the one before, right, in the original list. So this is the one method. Another method is reverse a linked list. So this is also a very standard task. So what we are going to do, let's see, we have pre, we have current equals, we still use null and the height, right? And then while current, first I'm going to, because we want to use this current pointing to previous, right? So first we need to get save the current next, right? Then we reset, right? So first we want to reset pre equals to the current, and then current next is going to be pre. Let's see, we need to do this first. Current next will be previous. So now after we do this, we set previous to be current and the current to be the next one in the original list. This is our order. So what we want to return is the previous. The reason is that after we exit this while loop, the current will be a null. Then the previous one should be, if it's not null, should be the height of the reversed linked list. So with that done, let's first check the this one, find mid and its father. So let's see, previous and slow. Let's directly call this one. We can print previous and print slow. So let's run this. So for this example, so here let's see. This is the second one. This middle one, so it's corresponding to 1, and this is the pre. The middle one corresponding to 2, right? Then pointing to now, and the previous one is 1 pointing to 2. So it's better to see this example because it's much better. So because it contains 4 nodes. Let's do see 1, 2, 2, 1. So the middle one is actually corresponds to this one. So you have 2, you point to 1. And then the previous one will be this 2, pointing to 2, pointing to 1, right? 2, 2, 1. So you can also try another one. So for example, you have a odd length. Then the middle should point to 3. Yes, 3, right? The previous one will be 2. So this is correct. So now let's look at the problem logic, right? So we have this one. So slow will be the this one, the second half, the height of the second half of the list. And then what we want to do, first I want to break the link, right? Break the linkage. So this is to avoid cycle, right? So if previous is not now, so we can set previous next. Originally it points to slow, right? Now we want to point to now, so that we break this one here, right? So with that done, so we can reverse the second half, the second half. So this is actually very easy. So we can call it head 2. So this is a reversed linked list. The list we want to reverse actually is this slow, right? So if you print head 2, so here, let's see, let's run this. For this example, it will be 1.2.23, you know, 1.2.3. This is right. So with that preparations done, with those preparations, we can do the check, right? So now we have 2 heights because 1 is this half, the height is the original height, and then we have the second part, this with height 2, right? So we just need to do well height and height 2. So these 2 can be different by 1 element when we have you know, odd numbers, but this will be fun because if we have odd numbers, for example, we have 1, 2, 3, 2, 1. The 3 is we don't need to compare, right? So in other words, one height will have length 3, the other height will have length 2. They differ by 1, but this is totally fun. So if height value does not equal to height 2 value, so we are going to return false, right? Otherwise, so we set height equals height next, and height 2 equals height 2 next. And then afterwards, if nothing has returned after this while loop, we just return true, right? So this is the second solution we want to explain. So here, this solution in time complexity is 01, and in space is 01. The reason is that, you know, we just do the operations in place, and also Python is passed for Python functions. The argument is passed by reference. That's why it's 01. So let's do a quick check. Yeah, it passes this quick example. So now let's look at the generic case. Yeah, it passes all the generic cases. So that's basically about it for this problem. So here we presented 2 solutions. The first one is sort of straightforward. Yeah, most people can come up with it. And the second one is a little bit tricky, but if you have practiced a decent amount of LeetCode problems, or you are very familiar with the linked list operations, the second method is also straightforward, and especially after you decompose the task into small tasks and resolve each small task individually. Like here, we write two hyperfunctions. So with that said, I guess that's it for the current problem. Thank you for watching.